Everyone, good morning to all of you. So today I will discuss transition and inner transition metals and complexes. Okay, this is a new chapter. The chapter consisting the topics are this, and I have divided into three parts. First one is the characteristics or general characteristics of D block element, then coordination compound, nomenclature, isomerism and bonding in complexes, VV theory and crystal field theory. Werner's theory, En metal carbonyls, cyclopentadiene, olefin and acetylene compounds. Next topic, compound with metal-metal bonds and metal atom cluster. Next, general chemistry of A block elements, lanthanoids and actinoids, oxidation state, magnetic and spectral properties. Okay. So basically I have divided these topics or these chapters into three parts. Okay. So first I will discuss in this video just the characteristics or general characteristics of D block element. So basically the concepts are there. At first we have to know there are mainly 4 series of transition metal. Okay, so first one is 3D, then 4D, then 5D, then 6D. 3D series consisting scandium to zinc, next 4D Y2 or yttrium to CD, that is cadmium. Okay, next 5D lanthanum and hafnium to Hg, then 60 series that is actinium RF to Cl. Okay, next electronic configuration. This is very important for us. The steric mark are very important for your exam point of view. First one is for scandium, that is argon 3d1 4s2. Titanium, that is 22 atomic number, that is argon 3d2 4s2. Next vanadium, that is 23 atomic number and that is 3d3 4s2. Next chromium, that is exceptional electronic configuration, that is for stability, that is this is 3d5 4s1. Okay, next manganese, that is 3d5 4s2 and iron 26 atomic number, that is 3d6 4s2. Cobalt, that is 3d7 4s2. Next nickel 3d8 4s2. Next copper, this also have the except electronic configuration, that is 3d10 4s1. Okay, due to stability. Next zinc, that is 3d10 4s2. These all are the electronic configuration. You have to remember all atomic numbers and the electronic configuration. Okay, and basically chromium and copper oftenly asked in the exam due to its exceptional electronic configuration. Okay, you have to remember this. Next, general characteristics of transition element. Basically from this topic the questions are not asked, but in your syllabus it is concluded, so I have just added this topic. First one is the all transition elements have metallic character. Okay, the metallic character, that is tensile, ductile, malleability, high thermal and electrical conductivity, etc. Okay, next, except mercury, which is liquid at room temperature, other transition metal have typically metallic structure. Okay, next they have high melting and boiling point and have higher heats of vaporization than non-transition elements. Okay, for the transition elements have very high densities are compared to the metal of group 1 and group 2, that is S block element. Okay, next, the first ionization energy of D block elements are higher than those of S block elements but are lesser than those of P block elements. Next, these are electropositive in nature. Okay, 7, most of them from colored compounds. Okay, next, they have good tendency to form complexes, that is the coordination chemistry. Basically from D block transition elements the coordination chapter is formed. Next, they exhibit several oxidation state. Their compounds are generally paramagnetic in nature. Okay, next, they form alloys with other metals. Okay, that is brass, bronze, etc. Next, most of the transition metals such as manganese, nickel, cobalt, chromium, vanadium, platinum, etc., they have been used as a good catalyst. Okay, so basically general properties that concludes all the ionic radius, metallic character, magnetic property, color, etc. So these are I have just discussed in very briefly, and these are very important in your exam point of view. Okay, so let's start it one by one. Next, first one is ionic radii. In general, the ionic radii decreases with increase in oxidation state. We know that. For this same oxidation state, the ionic radii generally decreases with increase in nuclear charge. Okay. Next, metallic character. All transition elements are metals. You know that. The hardness of the metals suggests the presence of strong bonding due to overlap of unpaired electron and between different metal atoms. So number of unpaired electron when increases, the metal bond strength is increases. Okay. Next, ionization enthalpy, that is also increases left to right in a period. Okay. Next, oxidation state. In a transition element, the common oxidation state is +3. Okay. And here a maximum time question asked from manganese 2 plus, that this shows +7 oxidation state, that is highest oxidation state. Okay. And oftenly asked, that is zinc, which element have only one oxidation state, shows that is +2, that is zinc. Okay. Next, formation of colored ions. Okay. So basically from this topic, this is very important from your exam point of view. So in a short video, I just remember this from this topic. I have uploaded a short video. Okay, which with tricks. So generally transition metals element shows color, but D0 and D10 colorless. That is included for D0 and D10. That is D block element, but transition elements D1 to D9. Okay. So titanium, that is titanium 3 plus, that is D1 electronic configuration, that is purple color. Okay. Vanadium 4, that is also D1, but it is blue color. Vanadium 3, that is D2 electronic configuration, it is green color. And vanadium 2 and chromium 3, that is D3 electronic configuration, it is violet color. Chromium 2, that is D4 electronic configuration, blue color. Manganese 3, that is D5, that is it is manganese 3, that is D4. Okay, it is D4, this is violet color. Okay. Next, manganese 2 D5, that is pink color. Iron 3, that is D5 yellow color. Iron 2 D6 green color. Cobalt 3 plus, that is D6 blue color. And cobalt 2, that is D7 pink color. Nickel 2 D8 green color. And copper 2 D9 blue color. So basically it have difficult to remember, but I have some tricks, so I just upload in the short video for remember these tricks. Okay, so you can go through the link and watch this. Next, 6, that is magnetic property. The magnetic moment is determined by the number of unpaired electrons. You know that, and is calculated by using the spin only formula for transition element. Okay, so here the formula is root over mu spin only value, that is root over n into n plus 2. N is equal to number of unpaired electron. So here D0 D10, that is there is unpaired electron is 0, so mu spin only value is 0. For D1 and D9, that is there is unpaired electron is 1, so value is 1.73. D2 and D8 electronic configuration, number of unpaired electron is 2, so 2.84. Next, D3 D7, that is electronic number of unpaired electron 3, so 3.87. 4 and 6, unpaired electron is 4, so 4.90. And D5, that is unpaired electron 5 and 5.92. So basically the values are corresponding to the unpaired electron, number of unpaired electron, and the value is just increases some decimal. Okay, so these are the values you have to remember, and this is very important from your exam point of view. Color and magnetic property and catalytic properties and alloy formation. Okay, these are the very important from this D block element. Okay, next, catalytic property, that is iron molybdenum. These two are used in Haber process. Okay, ammonia production of ammonia in the Haber process. Next, nickel, palladium, platinum, these are used in hydrogenation. Okay, V2O5, this is used in oxidation of SO2 to SO3 in the contact process for the manufacture of H2SO4. Next, MnO2, that is used in decomposition of H2O2. Okay, so you have to remember this. Next, alloy formation. These two alloys are I just included here, but you have to remember that is steel. Okay, brass is combined of copper and zinc, and bronze is combined of copper and tin. Okay, so these are all about D block elements. You have to remember basically the important topics are here, that is color, magnetic properties, alloy formation, okay, and catalytic behavior, and electronic configuration also, the exception copper and chromium. Okay, so thank you.